Okay, so we talked about enthalpies, but it turns out we can actually experimentally calculate enthalpies of reactions, and so we have a really big list of them. So standard enthalpies, which are used, the symbol is delta F H prime. So whenever you see the prime, it means standard, which usually means standard temperature pressure. The F means a formation. So it's the delta F, it's the delta H of formation under standard conditions. And these are experimentally determined, and there's 0 for elements. And it's specific to temperature and pressure. The naught usually means the 0, the prime, usually means that it's under STP. So here's a list. Okay, so basically, you've got your different substances, and then you got the formula. For elements, O2, F2, N2, Fe, it's always going to be 0. Okay, so what you can use these for is you can calculate the enthalpy of a reaction using standard enthalpies of formation. And so here's the formula to do that. It looks crazy, but it's really straightforward. Delta H is equal to the sum, sigma is the sum, of the stoichiometric coefficients times the enthalpy of formation of the products minus the sum of the stoichiometric coefficients times the enthalpy of formation of the reactants. Okay, that sounds crazy, but it's really straightforward. So let's look at it in action. Okay, so what is the enthalpy for the reaction? Of reaction for the combustion of glucose. So glucose combusts following this reaction. 1 glucose plus 9 oxygens gives me 6 carbon dioxides and 6 waters. Okay, here's my formula. So what are my products, right? What are my heats of what are my products? Well, I've got 6 of each, and my heat of formation for carbon dioxide is here, and my heat of formation for water, it's liquid water, so here. Okay, and then for my reactants, I've got glucose, and then I've got oxygen, which is going to be 0. So 6, right, times the delta H of carbon dioxide plus 6 times the delta H for water, okay, all of that added together, minus 1 times the formation of glucose, plus 9 times formation of oxygen, with a 0, so we simplify that, okay, and simplify it again, and there you go. It's negative 2,803 kilojoules per mole. So it looks complicated, but it's actually really straightforward. So here's one for you to practice. Sodium carbonate reacts with hydrochloric acid to form sodium chloride, water, and carbon dioxide according to the following reaction. Sodium carbonate plus 2 hydrochloric acid gives you 2 NaCl plus water plus carbon dioxide. Find delta H. So we look up here and we see okay, carbon dioxide. We find hydrochloric acid. We find sodium chloride here. We find sodium carbonate here. And we find water here. So we're going to say, okay, so it's equal to the sum of the products, so 2 times NaCl, which was negative 410.9, plus 1 times water, which was negative 285.8, plus 1 times carbon dioxide, which is negative 393.5, minus 1 times sodium carbonate, negative 130.9, plus 2 times hydrochloric acid, negative 92.3. So all of this minus all of this, and you get negative 118, 1185.6 kilojoules per mole. That's all it is. It looks way more complicated than it actually is.